For the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on the periodic properties within a group. In our last lesson, we discussed some general trends in properties of elements down a group of the periodic table. Specifically, we discussed nuclear charge and atomic radius. In today's lesson, we will learn about two more general trends, including ionization energy, or potential, and electron affinity. Let us get started. Ionization energy is the minimum energy that is required to remove the outermost shell electron from an isolated gaseous atom or ion. Students, please look at this equation. It represents ionization energy. The M denotes any metal. The electrons in an atom can be successively removed one after another. Therefore, the first ionization energy is the amount of energy that is required to remove the first valence electron. The second ionization energy is the amount of energy that is required to remove the second valence electron, and so on. Students, please answer the following questions. Which ionization energy is higher? The first one or the second one? Is ionization energy an endothermic process or an exothermic process? Is ionization energy a positive or negative value? Write your answers down on a sheet of paper, and we will go through the answers together in a few minutes.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Hello, everyone. You were correct to say that the second ionization energy is higher than the first. Ionization energy is an endothermic process. This is because energy is required in order to remove an electron from an atom. You were right to say that ionization energy is always a positive value. Let us continue with our lesson. Ionization energy is the tendency of an atom to lose an electron. For example, metals have low ionization energy. Therefore, they lose electrons easily. Non-metals have high ionization energy. Therefore, it is not as easy for them to lose electrons. There are several factors that can affect ionization energy, including atomic size, effective nuclear charge, types of electrons, the screening effect by the inner electrons, and electron configuration. Let us go through each factor in more detail. As the atomic size increases, the valence electrons become held less tightly by the nucleus. Therefore, less energy is needed to remove these electrons. For example, less energy is needed to remove an electron from a cesium atom than a lithium atom, because the cesium atom has a larger atomic size. Less energy is required to remove electrons from atoms that have smaller effective nuclear charges. When electrons are close to the nucleus, it is more difficult for them to be removed. In a given energy level, S electrons are closer to the nucleus than P electrons. Similarly, P electrons are closer than D electrons, and D electrons are closer than F electrons. Ionization energy decreases in this order. Each of these represents a sublevel or subshell. As you already know, inner shell electrons screen the valence electrons from the nuclear charge. The more inner electrons there are, the higher the screening effect. The higher the screening effect is, the easier it is to remove valence electrons. Thus, screening decreases the amount of ionization energy that is needed. It is easier for electrons to be removed from unstable sublevels than it is to remove them from stable ones. Those that are half or completely filled are more stable. Often, with the increasing atomic number, the first ionization energy decreases down the same group. Let us now move on and discuss electron affinity. Non-metals gain electrons. As a result, they form negative ions. The tendency of an atom to form a negative ion is expressed in terms of electron affinity. It is the energy released when an electron is added to an isolated gaseous atom to form a gaseous ion. Electron affinity is the strength of an atom's ability to attract an extra electron. Energy is released during this process. Therefore, it is expressed as a negative value. Let us look at an example. When a fluorine atom gains an electron, 328 kilojoules per mole of energy is released. This produces a fluoride ion, and the electron affinity is minus 328 kilojoules per mole. The smaller the atomic size of an atom, the stronger its tendency will be to form negative ions. Thus, it will have a higher electron affinity. Therefore, electron affinity is often dependent upon the atomic size and effective charge of the elements. Students, let us do one more activity. In a moment, you will see the list of factors that affect ionization energy. Please describe the effect that each factor has.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. As atomic size increases, less energy is required to remove electrons. Smaller effective nuclear charges also require less energy to remove electrons. The closer an electron is to the nucleus, the more difficult it is to remove the electron. The more inner electrons there are in an atom, the easier it is to remove electrons. Finally, it is easier to remove electrons from unstable sublevels rather than those that are stable. In today's lesson, we learned about ionization potential and electron affinity. We discussed these as the general trends in properties of elements down a group of the periodic table. This brings us to the end of our lesson for today. Until next time, thank you, teacher. Thank you, students.